Okay, it looks like we have an interesting Cambridge integral. So we have integral from 0 to pi 2x cubed minus 3 pi x squared over 1 plus sine x squared dx. This integral looks a bit messy, but if you spot the hidden structure, then it becomes really cleaner. So the first thing we can do is work on your numerator. We have 2x cubed minus 3 pi x squared. If you factor x squared out, then we have x squared parentheses 2x minus 3 pi. But this expression, x squared times 2x minus 3 pi, does not really help alone. So that's why I'm going to be looking at the symmetry of this integral from 0 to pi, right? So let me just make a substitution. Let me call x as now pi minus t. Then the lower bound and the upper bound doesn't really change. It is from 0 to pi after reversing it, right? Then at the same time, we can use the sign of pi minus t. This is just the same as sine of t. So that is why, let me just call this integral as the I. And we can represent this I as integral from 0 to pi. And then we should have 2 parentheses pi minus x cubed. And then minus 3 pi times pi minus x squared. That over your denominator the same as 1 plus the sine of x squared dx. I'm still using this x as a variable. Just keep the notation simple, right? And at the same time, if you work on your numerator part, it is going to be now 2 parentheses pi minus x cubed. And then minus 3 pi parentheses pi minus x squared. And if you expand everything, this is the same as the negative pi cubed plus 3 pi x squared. Then that minus 2x cubed. So let's use this as your numerator for this integrand, right? Then your integrand I is the same as integral from 0 to pi. And then we have negative pi cubed plus 3 pi x squared minus 2x cubed. That over your denominator of still 1 plus sine of x squared. Then we have dx. Okay, this was the original integral, and this is a transformed integral I. So these two integrals are just the same integral I, right? So let me just add them up. So if you add them up, then we should have now 2I, right? 2I is going to be then the same as integral from 0 to pi still, and then we have 2x cubed minus 3 pi x squared, parentheses, and plus negative pi cubed, and plus 3 pi x squared minus 2x cubed. The whole thing divided by 1 plus sine of x squared, then we have dx. And surprisingly, many terms on your numerator cancel out. So it looks like negative 3 pi x squared and 3 pi x squared cancel out. And then we have 2x cubed, and then negative 2x cubed cancel out. So it looks like we have only negative pi cubed that is left on your numerator. So this integral is the same as then integral from 0 to pi of just negative pi cubed over your denominator, 1 plus the sine of x squared dx. That is equal to 2 times I. So from this, we can rewrite this I as pulling this negative pi cubed outside of your integral, right? And then you divide both sides by 2. So it's going to be negative pi cubed over 2 times integral from 0 to pi of just 1 over 1 plus sine of x squared, and then we have dx. So we can work on this integral. Integral from 0 to pi, 1 over 1 plus sine of x squared dx, right? So let me just call this integral as j and work it out. So once again, integral j is the same as integral from 0 to pi of 1 over 1 plus the sine of x squared. Then we have dx. And let's use a little trick about this 1 plus the sine of x inside of your denominator. So we can represent this as now sine of x plus 1 over 1. And then let me multiply 1 minus sine of x to both your numerator and denominator, right? So multiplying 1 minus sine of x to your numerator and denominator. Then your numerator is becoming now cosine square x, right? So your numerator is then cosine square x, that divided by only 1 minus sine of x. And since we have cosine square x over 1 minus sine of x, right? Then 1 over 1 plus sine of x squared is going to be 1 minus sine of x squared over cosine to the power of 4x. So let's just rewrite this, right? So that's why 1 over 1 plus sine of x squared is then going to be 1 minus sine of x squared, and over cosine to the power of 4x. And then this is going to be then the same as 1 minus sine of x squared still for your numerator. And denominator is going to be then 1 minus sine square x squared. So that's why we can make another substitution. Let me just call u as tangent of x over 2. Using this, your sine of x is then going to be, using the u, it has been now 2u over 1 plus u squared. And of course, dx is going to be then the same as 2 du over 1 plus u squared. So let's use this expression, right? So using this expression, then we can have now 1 plus and 1 plus sine of x. This is going to be then the same as 1 plus 2u over 1 plus u squared. That's going to be the same as then u plus 1 squared. That's over 1 plus u squared. Okay, so u plus 1 squared over 1 plus u squared is what we have for this 1 plus sine of x, right? And then dx over 1 plus sine of x squared. So what this means, dx over 1 plus sine of x squared. So we can rewrite this as 2 du over 1 plus u squared. Okay, then that times 1 plus u squared squared. That over u plus 1 to the power of 4. Okay. So after canceling out, then this expression is the same as 2 times 1 plus u squared. And then that over u plus 1 to the power of 4 du. So the lower bound and the upper bound, right? Using the u. So when x is going to 0, then your u is also going to 0. And then when x is going to pi, u is going to infinity. So the lower bound is now 0, upper bound is now infinity, if we're using u as the variable. Okay, so your integral j is then the same as integral from 0 to infinity. And then that of 2 parentheses 1 plus u squared. That over u plus 1 to the power of 4. And we have du. Okay, time to work on another substitution. So let me just call v as u plus 1. Okay, then your u is going to be equal to v minus 1. So that's why using this, we can rewrite this integral j as pulling this 2 out. 2 times integral from, say, 1 to infinity. Okay. So the lower bound and the upper bound should be changing from 1 to infinity, that of v squared, and then minus 2v, and plus 2. That over v to the power of 4. Then we have dv. So it looks like we can split this integrand into 3 fractions. So we can rewrite this integral j as now 2 times integral from 1 to infinity. Then that of 1 over v squared minus 2 over v cubed, and then plus 2 over v to the power of 4, and then we have dv. So that we can evaluate these three separate integrand, right? So for example, integral from 1 to infinity, 1 over v squared dv is equal to 1. And integral from 1 to infinity, 1 over v cubed. That is now 1 over 2. And then integral from 1 to infinity, 1 over v to the power of 4, that is 1 over 3. So that's why what we have is going to be 2 times parentheses 1 minus 2 times 1 over 2. And then plus 2 times 1 over 3. So if you calculate this, it has to be just the same as 4 over now 3. So the value of this integral j is now 4 over 3, that we should multiply that to negative pi cubed over 2. So that's why the answer for this question, I, is going to be negative pi cubed over 2 times 4 over 3. That's going to be negative 2 pi cubed over 3. So negative 2 pi cubed over 3 was the answer for this question. Okay, so pretty interesting integral from Cambridge Integration B. How amazing.